Most of these next settings are going to be left at the default. As if you read down here in the field description, they are giving what the default tolerances are. So I'm going to make this one 0.005, and you may need to increase the precision so that you'll be able to see that. And we have the maximum trials per time step. Again, the default value for this is 8. You get the choice if you want the inertial terms of the St. Bernard momentum equation to be handled. So you can either dampen, ignore, or keep. The variable time step is computed for each time period to prevent an excessive change in water depth at each node. And then if you have this set to true, then you will be choosing that time step multiplier here. Next, just select the basis used to determine when supercritical flow occurs in a conduit. So you could either do the Froude number, slope, or Froude and slope. The minimum surface area. I'm going to leave this set at 0, and then that will be a default value of 12.566 square feet. This next value I'm going to leave at 0, and that will mean that no conduits will be lengthened. I also have a minimum variable time step, which I will leave at the default of 0.5. And then lastly, we have the number of threads. With the explicit solver, you can also take advantage of multi-threading available in modern CPUs, most of which have multiple cores available for parallel processing. In the calculation options, we're to set this number of threads options to 4. If you're not setting it to 4, then you'll set it to automatic. Now we'll go into the swim hydrology section. So here you'll set the increment for the time step length used to compute runoff using the EPA swim runoff method. So this is only going to apply if you are using that runoff method. And you can also choose the number of days with no rainfall prior to the start of simulation, the time step length used for runoff computations during periods when there's no rainfall or ponded water, and then swim interface files. Right. So by default, I'm going to leave these all set to none and false, and then per project, if these need to be loaded, they can change that there. If you are going to check for water quality, you can say true or false to run the hydrogen sulfide analysis. Do you want to consider non-pipe plunging flow? So if this is set to true, the calculations will apply the plunging correction factor for non-pipe flow. And then down here in the HEC 22 energy losses for third edition, if you are using this method, you're going to want to go through and make sure that the coefficients are correct. And then the last setting is going to be whether or not you want to apply pipe blockages.